Hello, my name is Evan Schwartz, and we're going to look at Rollimole unit testing, and we've created 10 unit tests. And what I'm going to do here is I'm going to let it play through, and then we're going to talk about the failed tests. We'll look at the code, we'll go through, and we'll find out while each test failed. We'll get the code fixed, and then come back and rerun them again. So I'm going to apologize up front. I'm having to load the scene, and on scene load, there's a audio effect that plays every single time. So you're going to hear this 10 times. So just bear with me. Okay. So all 10 of our tests, again, sorry for the monotony in the sound. All 10 of our tests ran. We're gonna talk about these special and this one special. So we're gonna start down here at no negative worms. What's the intent of no negative worms? As you're scoring points, the assumption is you're killing a worm. That's the only way you can score points. But you should never be able to score down to negative target worms. So each level has a target number of worms. Let's just say 10, and you shouldn't be able to kill more than 10 worms, right? You shouldn't have a negative worm condition. Negative values have a tendency to throw off formulas. So this is just making sure that the reverse accumulator, right, doesn't take into the negative. Valid level timer. What this is doing is as you go from level to level, you have so much time to kill the target number of worms. So this basically stress tests what the level is, what we anticipate the number of target worms to be, and then how the calculation for time works, and to make sure that that is consistent with our expectation. So this is just making sure that your level timer calculates out properly. Valid loss test. This is testing the lose condition to make sure that as you go through, your state is properly managed. You get some cleanup and you get the appropriate text back. The text is just a simple way of knowing, hey, did it go through the calculator and go, yep, you lost, and send that back to you. So that's sort of my Boolean switch tester there. Valid number of worms. So you have a couple of hits. So once you're go to a level, you have a number of worms that's your target. So at level 1, you're trying to kill 5. At level 2, you might try to kill 10, and so on. So as you go up more and more levels, you have to kill more and more worms. This makes sure that based on the level that we push into the test scenario, we get back the target number of worms I have to kill that was expected. That's kind of key to the balance of the game and the progression through levels. Valid stabilize. It's possible, we didn't test on every possible device in the world, that as our platform and tilts and moves around and the gravity is pulling on the ball, that it doesn't flip out and fall out of the platform. So we have a stabilize button over here that you can click that will reset the game board and put the ball back into the game board to allow you to keep playing. Otherwise, it creates a stop condition in the game. So this is just sort of safety. What this one is making sure is that when you click that, the ball is put back onto the board so that the game can continue. We figure that's kind of important. And valid worms by level, where we were testing what's the total number of targeted worms we have to kill for that level. Only so many of them should show at any given time. So, for instance, on level 1, you should only see one worm at a time. So you got to kill it before the next worm comes. Level 2, you're seeing 2 worms at a time, and so on. So what this makes sure is it's going to stress test the creation of worms and make sure that it is adhering to the rule that you can't have more worms than there is the current level set. So that's the basic test. Let's talk about our special ones, the valid stabilize and then our clamping. So the key mechanic in the game is the accelerometer. As I'm tilting and moving my device around, I'm causing the platform to tilt. But if I don't put any limits on that, the platform just keeps spinning. It spins completely out of control. It gets upside down. The ball flies all over the place. So to make the game worth playing, you want to clamp. You don't want it to tilt only to so far enough for the ball and gravity to take effect on the ball to get it to roll, but you don't want it to keep going around and around. That just makes it unplayable. So here I broke that test out into its individual components, and let me explain to you why. When I'm given a test or set up a test by one of my developers, I I need to know what is being tested by looking at that test. And then when we run the test, I want to know what the output is, right? Because my QA people do not have access to code. They have access to log into TFS, they can run the unit test, they can get the green arrows, they can pull the fail reports out and combine it to their total weekly QA report of all the things that broke. They do all kinds of tests and put that into a report and send that back to developers. And I'm a stickler that that report needs to be actionable. Don't just tell me it didn't work, right? Give my developers something to chase. So in this case, confirm floor clamped on tilt X high, and it failed. So I look at my fail report and it says I expected this to be less than zero point 0.2, blah, blah, blah. That's just precision in a flow. But it was 0.9. Okay, right here I can see I'm way outside the bounds of what I expected to be on the high end of my X tilt, right? So right away, my developer knows, all right, I'm tilting either low or high, right, on my X, and I have a break in my high. I'm not clamping that properly. It tilted way, way, way too far in the high, and he's already got a direction to go. They're already targeting what to do. So that's why we got 4 of these. So I come back and I look at my stabilize, my valid stabilize, the thing I don't like, right? If a developer gave me this, we'd have to have a little conversation at the end of the day. So here's what I don't like about it. It says valid stabilize. Okay, I get that you're testing my stabilize button. I'm able to glean that. Maybe a little bit better write up. But here's what I don't like. Expected 1, but it was 0. That doesn't tell me anything. Now, under the hood, we'll look at the code in just a minute. What it's actually doing, because it's important that the ball get back onto the playing field, what this test is doing is confirming that the ball's X, Y, and Z position exist where they belong, X, Y, and Z. In my shop, I would have asked them to break this up into the valid stabilize ball location X, Y, and Z and have 3 tests. So that if one of those coordinates is out of place, what was it and what was I expecting it to be is part of the report that's given to them. So now I have everything I need to give that developer to fix this. It's all right there, right? But for demonstration purposes, I kind of bundled it so that I could have this conversation. All right, so we already went through all the failed tests. Let's take a look at the code itself, and we'll go down these one at a time and kind of get them all fixed. So the first test is the confirm floor clamped on tilt X high. We just talked about it. So what is it doing? It's loading my scene. I have to yield a little bit just to give the scene time to load. I need access to my floor object. That's this guy over here, right? So this is my mono behavior for my floor, and it taps into the accelerometer input and does all the tilting. And then I just set up my vector. Typically, this is where the accelerometer data would go, and I'm pushing a high acceleration, like 0.5. That's an excessive amount of acceleration. You're probably going to throw your phone on the floor to get that. And then I set up my quaternion, and then I'm going to push this 100 times. So I'm accelerating faster than I should be in 100 iterations, and I'm sending that to my set floor method, which is ultimately this is what we're testing, right? This is the one line of code I need to test is can I send in acceleration information and make sure that the floor is doing what I want it to do. And then once I get my quaternion back, I test its X position and make sure that because I know I pushed it very, very far in that direction, that it's less or equal to that value. And if it's not, then it's failed. It means I didn't clamp that direction. And we do the same thing. Here's the high. It's a little bit different. I'm testing the low end side of it. So I'm at -2. So I'm between -0.2 and +2 on an axis. And here I'm pushing it at -0.9. Again, a ridiculous acceleration, running it 100 times and trying to get that in there. And we do that for all parts of it. So let's see if we can get these fixed. So being this is what I'm trying to fix, let me go to declaration. And I'm going to look in here and I've kind of set this up. Here's my failed test. And you can see that I'm just passing my transformation directly into my quaternion and returning the value. And what I really need to do is add some clamping to that, which is what we're doing up here. We're using the math clamp to clamp between what I got back in a report in my failed test, which was the -0.2 and 0.2, and we're doing the same thing in the X and the Y and the Z. Non-negative worm. So in this case, what I'm trying to figure is what is the worm target of 5? I want to make sure I'm basically giving myself 5 worms. And then I'm putting myself in a loop of 10 worms. So I still have the same thing. I'm loading up the game. I'm waiting. I'm getting an access to my game object at this point because I'm testing game logic and making sure it's not null. I don't want my test to blow up. And I'm giving myself 5 worms. I'm looping 10 times and I'm adding score of 1. So in this update, this of score, all it's really doing is supposed to be taking in the score, but it knows that for every time I score, whatever that score amount is, I'm killing a worm. So it's supposed to be deducting a worm. And I'm supposed to see it equal to 0 because I scored 10 times. There's only 5 worms, but it's not supposed to go below 0. So that's the nature of the test. If something's wrong with this, we'll go to this declaration. And what it looks like is, hey, maybe during testing I commented out a piece of code and I left it commented out. So we're going to go ahead and put that back. And what this is going to do is just make sure that if I dip using this command, if I dip below 0, set it back to 0. And that should make that test pass. Save all while I'm doing it. Valid level timer. So again, loading up the game scene, giving myself some time, grabbing access to the game object, making sure it's not null. So I'm going to start a level. So I'm doing my start level. This is really kind of testing my start level, and I wrote a little note to myself on how all the logic and formulas are supposed to work. So if the level is based on the worm target, so there's like 2 formulas happening here, and one is whatever the level is times 5. Therefore, if I'm passing in level 2 times 5, the worm target should be 10. And the level timer is a base of 10 seconds floating plus the worm target. So if I'm doing 10 plus 10, it should be 20. So that's really, I'm just putting up here in comments my assertion. So I set up my level timer and I get my level timer. So this is just an accessor after I've run the start. Tell me which the timer is, and then just to make sure that because it's a float value, and I do a couple of little tricks for this, but this is a popular one, that I can trim off that weird precision issue on float, right? This might be 20.00003f, but if you convert it to an integer, then you truncate this part of it, and it makes it easier to assert. Um, I've got developers that do it both ways, and you'll see another way that I do it. I sprinkled around just so we could see all kinds of options on this. But here I just convert it to an end to avoid float precision issues on an R equals, and I'm just testing against 20. So something's happening here in my start level, and I'm not getting the correct result. And what it looks like is I've got the wrong number here. So I'm going to comment this out and bring in the right number because the formula says 5, and that will give me the appropriate timer. Now, an interesting thing here is I fixed the worm target to do this, and I have, and that's an interesting thing. So there's the part of this month is to debate the value of unit testing. So my valid timer failed, and I've got another one down here, which is my worms by level, which is testing the worm target. This failed too. This one failed because of this, but I got the report back that the timer was wrong. That's a tough call, right? That's now we're into a logic decision. So in this case, fixing this worm calculation on the, I'm in the wrong one, game script, sorry. Fixing this worm calculation is fine. Fix not only the worm target test, but also fix the timer. So sometimes you get a twofer, but the point is I would have been chasing down, in this one, I would have been chasing down my timer to try to figure out what was wrong, when in fact it was my valid worms by level that was wrong. That's an interesting, we could get into a different discussion on how best to approach that. But in this case, since I'm passing in the same second level and I should have expected 10 worms, I kept my note here and I didn't get 10. When I go back to my test, and this is where the clue is. So valid, where is it? Valid worms count. I'm not seeing it. Valid number of worms. Valid worms by level. There we go. So what I expected was 10 and what I got was 6. So this could have been a clue if I was looking down my error report from QA that, well, yeah, the timer was wrong, right? Expected 20 and got 7, but also my worms by level was wrong, and that's probably where it is since the timer is based on that. Unfortunately, there's no real way to know. The developer wouldn't know that without digging a little bit into the code, so that's kind of a muddy area there. But in one fix here on the game script, we fix both of those tests, so that's kind of a gimme. Valid timer, valid worms. So this is the other method. I created a little helper function here, basically using the math epsilon to sort out floats if their precision is off, and just returns a true false as to whether or not they're equal. So this little helper function I put together to test things down here. Now this is the test I don't like, so let's spend a little more time on this. So I load my game level, I wait 2 seconds, I generate my game script, make sure it's not null, and then I call my stabilize, right? That's all I got to do. And all I'm looking for is to make sure that my ball is where it belongs, right? And it doesn't matter that the ball was set somewhere else. That's irrelevant because stabilize is a hard set to the ball to be at this location. And what it's doing here is I've created this fictitious value here, this return result. And I see this so often in unit testing, and I'm grandstanding here, I know, but setting the test result to 0, so I'm setting this boolean for the test to false, and then I'm testing the units, right? Now I'm really testing 3 units. This is the individual units. This is a bad unit test, and I hope everyone kind of understands why I think this is a bad unit test. Technically, yeah, the ball's where it needs to be, but I don't know when it fails, I don't know, is it the X, the Y, the Z, is it all of it? What is about the ball that's bad? I don't get that by having this macro unit test, right? This is a macro unit test. So anyway, I don't typically like these. We don't allow these in my development shop. So I just wanted to have both of those examples here to talk about that because I thought that was an interesting opportunity to demo that and testing against one. So how do we fix that? Something's wrong in my stabilize. Let's go take a look at that. And it looks like there may have been a typo here, or I mixed these two up. So once I realized, and again, from the unit test I built, I wouldn't have known, right? I wouldn't have known that this was supposed to be 1.0 up. But if I broke those out into 3 individual unit tests, I would have known, right? That, to me, that's the value of it. But here I just have to know. I just have to know that this is the right one and that's the wrong one. So the next one is valid number of worms. So this is where we get into how many worms are showing at the same time. So on level 2, I shouldn't have more than 2 worms showing at any given time. So I call the create worm method, and I want to say, hey, give me the worm count. Is it equal to 2? Right? I'm on level 2. I shouldn't have more than 2 worms, but I'm calling the create worms method 5 times. Um, and it's telling me I've got more. And if I go down to the um, number of worms, yeah, you'll see that it's saying that there's 7, but I expected 2 of them. All right, so something's wrong with my create worms. Let me go take a look at that and see what specifically. And it looks like, again, I've got a comment issue here where I may have commented out something for some reason and forgot to put it back in. So now I'm making sure that worm count is less than level before I create the next worm, and then I should be able to call this as often as I need to, since it's in my update, without it flooding the game board with worms. So that's an important one. And valid loss text, this is the final test. So this is me testing in-game condition. Load my scene, wait a couple of seconds. I need access to my floor. It controls that pop-up label in the countdown. And I'm passing into it, hey, floor movement game state loss. So I'm telling it, hey, we lost the game. Can you return the text and get the result? And this is what I wanted to say. And this is, I like these. I like these a lot. And let me show you why I like these. Because when I look at my valid loss text, look at this. All right, expected you lost replay level, but was you lost, right? Wow, that tells them exactly what the problem is. There's no doubt in anyone's mind what needs to be done there. So if we come in here and we look at our game state and see what's going on there, we come in here and it looks like we just put the wrong text in play. for this example just to make it work. And then it goes through and it does all the sound and sets up all of my play states and returns it back to me. And that stages me for my lost game. All right, so I've now fixed all of my unit tests. Let me go ahead and hit a save on this. Save all. And we'll let Unity kind of catch up. Looking for my little spin wheel. There it is. All right, and we're going to come back up here, and once again, I'm going to apologize in advance for the constant replay of that, and we'll see if we've passed them all. Okay, so it looks like we have passed everything except for the valid level timer, and what have we got? Expected a 20, but was 11. All right, so this is not an uncommon scenario because I've got my level timer and my number of worms are very closely related to their issues. So now we got to go back. So unfortunately, in my shop, this would have gone back because I would have been confident, hey, I know what the problem is. The worms were wrong, and that messed up the calculation of the timer, and I'm done, right? But the developers can run these too, and they should. So if this made it back to QA and the QA person had to tell me this failed, I'd be a little upset. All right, so now let's go back and let's re-look at our timer, right? Because our assumption was, well, we saw that there was a math problem, and these math problems are tied together because we had the wrong number of worms, but there's something else wrong, right? There's something else wrong in my start level. So now I need to go back to this and go, what's going on in my start level? Why is it not working? Ah, I overlooked this the first time. It looks like I got a typo. I meant to be 10.0 and I did 1.0. Well, bummer. All right, so now we're going to go ahead and fix this, fix my timer, and do a save on that. Come back over here to Unity, let it do its little pinwheel business. And these already passed. So I'm just going to pick this and run this one and spare you the 10 are you readies. And there you go. We got 10 green checks, and we've got our requirements in our business and our games in business. Thank you for watching. I hope you learned something.